Hello everyone, my name is Kristina Zhelaskova and I'm one of the engineers working on the IPAM integration in vRealize and vRealize Cloud. In this video, I'm going to show you how you can use the IPAM SDK and create your own IPAM plugin. Let's get started. I'm assuming you have already downloaded the source code of the IPAM SDK. There is an easy to follow step-by-step guide in the README. Before you start, make sure you meet all prerequisites. They are listed here. As noted in the README, the first step is to package the sample scripts. Before you run the command for packaging the scripts, open the source code and go to the POM XML file and change the name, the description, and the version of the provider. This will be displayed in vRealize. So let's change them. We also advise you to change the logo PNG file with an icon of your own logo. It will also be displayed in the UI. It is located under Source, Main, Resources, and here it is. This is the sample IPAM logo we use. If you want, you can also change how some specific fields during IPAM endpoint registration are rendered by modifying the endpoint schema.json file. You can also see that registration YAML file here. It contains meta information about the contents of the IPAM package. Don't change anything in it. Now run Maven package with the option for collecting dependencies. This will produce a zip file under the target directory. As you notice, this can take several minutes. This is due to the fact that the script attempts to collect any third-party Python libs that the plugin depends on. The next time you build the package, you can use just Maven package without this option, and the package should be built faster. In case you introduce a new third-party library, you should use this option again. We recommend you to go ahead and upload the sample zip in vRealize without making changes and make sure everything works. So let's do this. I'm logged in vRealize Cloud Assembly, and I'm going to show you how to create an IPAM integration that uses the package we just built and how to test it. Let's go to the Infrastructure tab, to Integrations. Let's click on Add Integration and choose IPAM as the integration type. From here, you can manage the IPAM providers. And from here, you can import the provider package. As you can see, it is located under the target directory. And I'll just wait for it to be uploaded. Okay, it is successfully imported. And as I told you, you can see the name, the version, and the description I entered in the POM XML right here. They're the same as in the POM. So let's choose this package here. And I don't have other options since I haven't uploaded other packages. Let's just enter some random credentials because the sample script doesn't actually validate them. And the hostname should be the hostname of the IPAM provider, but for now, choosing http://bin.org is just enough for testing the sample code. Let's just give it a name. And you see this running environment field. Let me just show you what you see if you use the SaaS version of the product. If you add an IPAM integration, here you see a drop down with cloud accounts that are able to run the ABX actions. The running environment actually is what executes the scripts that implement the IPAM operations, and it is based on ABX actions. And you can use AWS Lambda or Azure Functions or extensibility actions on-prem. If the external IPAM system instance is running in a private data center, you should use a cloud extensibility proxy in order to be able to connect to the external IPAM system. So if this is the case, you should go to integrations. I'll just discard that and add an integration with extensibility actions on-prem type. And you need to choose an extensibility proxy or create a new one and deploy it in your data center. So if the case is that your IPAM system is running in a private data center, just follow the steps I showed you. Now let's go back to the on-prem version and click on Validate. This triggers the Validate Endpoint action run, which we can go and see in the Extensibility tab. Under Action Runs, under Integration Runs. We see that this action is being deployed. And we saw that it completed successfully. So let's click on Add. And the endpoint will be created and the data collection should start. The data collection is actually the execution of the get IP ranges action, which collects ranges and networks from the external IPAM system. We see it here. And we also see other actions, allocate IP, deallocate IP, and update. And this is just an optimization we do. This pre-deployment of these actions will make the next action run faster because it will already be deployed. Let's just refresh this and we see that the get IP ranges action is running now. And we see that it completed successfully. So let me show you how you can provision a machine and assign it an IP from the external IPAM system in order to test the allocate IP action. First, you need to set up a network profile. I'm going to use this network, which is data collected from the data center, and it does not have a configured CIDR or gateway or other settings. Okay, I'll add an IP range from here, and I'll use the network I just showed you and the IPAM integration I created. These ranges we see here are the ones that were data collected with the get IP ranges action. Let's open the code of this script and see what it does. It is located under source, main, Python, validate endpoint, get IP ranges, source py. What we see here is that the action returns some hard-coded ranges. And we see that actually these are the same we see here. Okay, so let's choose the second range and assign this network to it. Now we can create our network profile. I'll add a capability tag, which I'll use in the blueprint after a minute. And I'll add the network I just told you about. And as you can see, there is this range I just added. Let's create this network profile and let's create a project. And add the same cloud zone as the one of the network we chose. Let's create a project. And we are ready to create a blueprint now. Let's go to the Blueprints tab, create a new blueprint. Let's choose the project we just created. And let's add a machine and a network. It is required to choose a static network assignment. Let's choose an image and flavor for this machine. Okay. And let's add a constraint in order to use the network profile we just created. Let's deploy it. And this should trigger the allocate IP action. Let's go here. And we see that the allocate IP action was triggered and it completed successfully. So we don't need to wait for this deployment. We just will cancel it. And we'll delete it. And this should trigger the deallocate IP action. Okay, just wait for the deallocate IP action. And yeah, it completed successfully. Great, everything looks fine. We've tested all 4 of the required IPAM operations. So let's see the next step. It is to get familiar with the IPAM operations and their skeleton implementation. In this table, you can see all IPAM operations with a short description. There is also a path to the script you should change in order to implement the logic about the corresponding operation. You can also see whether it is mandatory to implement each of these operations. As you can see, we've tested all required IPAM operations, which are allocate IP, deallocate IP, get IP ranges, and validate endpoint. So let's go to the next step, which is to implement the IPAM operations. You can see in what order we advise you to implement the operations in the README. We strongly advise you to implement one IPAM operation, then build a new package, upload it, and test that it works. After that, implement another one and do the same, and so on iteratively. So let's start with the first one. Let's implement the validate endpoint action. Okay, as described in the README, there is a skeleton implementation of all operations, so it is quite easy to write your own implementation. There is an example payload of every operation. You can also see information about the operations input and output in the documentation referenced in the README. Let's open this. And there should be a table here with the input and output of each operation. For example, we are implementing the validate endpoint action. And here we can see the properties in the input with a short description, their type, and whether they are optional or not. The handler function is the entry point into the IPAM operation. All you need to do in order to implement an operation is add your specific logic in the places indicated by the commands. Everything else is already done for you. For example, there is a code that gets the credentials, and they're already here for you. And you can use them. In order to test this, you can in order to implement this, what we can do, for example, we can just call some REST API. And for this example, I'll use the Infoblox REST API to get all networks with the specified credentials. If this succeeds, then the credentials are correct. Okay, so I'll use the requests library in order to make the call. I should pass the URL, and here I should write the host name. And as you can see from the example payload, it is right here in the endpoint properties. So I can get it in this way. This is the base URL of the Infoblox API. And as I told you, I'll get all networks. And I should pass the certificate in this case, and the username and password in order to authenticate. Okay, this looks fine. So let's just go ahead and build this package. And this time we don't need to collect the dependencies again, since we haven't introduced any new third-party libraries. Okay, it was built successfully. Let's go into VRA and go to integrations and add a new IPAM integration. I'll import the new package. And it asks me whether I want to update it because I didn't change the version. I'll just update it. Okay. This time we need real credentials. And I need the host name of the Infoblox instance I am using. Just copy it and paste it here and click on validate. This time, this should connect to the Infoblox instance and do a real validation of the credentials I just entered. Let's go to the extensibility tab, and we should see the validate endpoint action. Okay, it is being deployed, just takes a little time. Okay, the Infoblox uses a self-signed certificate, so I should accept it. And the credentials were validated successfully. Just to show you that this time it really does a validation of the credentials, I'll enter something random here and click on validate again. It should trigger a new validate endpoint action, and it failed. like we expected. And you can see the log here. And you can see this invalid credentials error. So the action seems to work just fine. Okay, after we tested this operation, let's go on and implement the next operation in the list, which is get IP ranges. Okay. You already saw that this sample code returns some hard-coded ranges. We are going to code the Infoblox REST API for this example and get some IP ranges. Here is the call I'll make in the code. I'll just show you what it returns. It returns two IP ranges. Okay. So let's just use the requests library again in order to make this call. I will use the host name again, and this time it is located in the inputs in endpoint and endpoint properties. So, okay, let's get it from here. Actually, I'll just pass it as a parameter. Again, this is just the base URL of the Infoblox API. And as I told you, I'll get the ranges, and I'll just get the ranges from a specific network view, which is just a logical grouping of networks. Okay. I'll just pass the host name as a parameter here. And again, I need the certificate for validation and the username and password for authentication. I'll pass this as parameters too. Okay, so let's pass them. Okay, this should work. And let's pass the certificate, the username and password, which are already there for you. And now let's get the body of the response as a JSON. And let's return the ref you saw as an ID. And here, let's return the start address. Okay. And also the end address. This is just for simplification of the example. Okay. So this way, we should see the ranges we see here when the get IP ranges action is triggered. So let's go ahead and build this package again. And let's upload it here in vRealize. Let's give it a name. And let's import the package with the new implementation. Again, let's update the package. And let's copy the host name of the Infoblox instance. Let's click on validate and see that the action is triggered here. Okay. It completed successfully, and we can add this endpoint, which will trigger the get IP ranges action. Again, you see this pre-deployment we do. It is being deployed now. Let's refresh this. Should finish soon. Okay, it completed successfully, and let's see what it returned here in the outputs. We see this ID and this start IP address and this end IP address, which we can see that are the same as here. And because we use pagination, here we see just the first IP range and the next page token. So we should see another get IP ranges action, which should return the second IP range. Yeah, we see this start and end IP addresses, and we see that they are the same here. So our implementation works as expected. And continuing this way, after implementing each operation, just build the package, upload it in vRealize, and test whether the new operation works as expected. And as specified in step 4, you should add all third-party libraries in the requirements file of the corresponding IPAM operation. For example, if you use some third-party library for the validate endpoint script, you should add this library here in its requirements txt file. It is important to note that you should always rerun Maven package with the collect dependencies option every time you add or remove a new dependency from this requirements txt files. Okay, so in step 5, we explain what property in the POM XML you should change if you choose to implement some of the optional operations. Let's go to the POM XML. And for example, if you choose to implement the update record operation, you should set this property to true, support address update record. And if you choose to implement the allocate IP range action or in the allocate IP range action in get IP blocks, which you see in this table, the last three, which are optional. And then you should set the property supports on-demand networks to true. In case you support address spaces, which are logical groups of networks, you should change this property to true. If you ever change, for example, this property, you have to rerun the build with Maven package collect dependencies, since the dependencies for this update operation would need to be recollected. Okay, after you implement all the required operations and some of the optional ones, if you choose to do so, just build the package and it will be ready to be distributed and used. That's it. Thank you.